The higher the chi-squared value, the lower or higher the p-value, and the more or less likely that the observed values would have occurred under the null hypothesis. So I'm going to put our chart on the screen so we can kind of use it to help us interpret. So let's just assume 2 degrees of freedom, right? So we have a 0.05 p-value, critical value, and a 0.01 critical value, all right? A 0.05 critical value represents that there is a 95% chance that the difference between the data that you expected to get and the data that you observed is due to something other than chance. In our example, where I said 3 degrees of freedom, the value would be 7.81. Okay, that's the threshold. If you reach that threshold or anything higher than it, then the expected data is significantly different from the observed data, and we reject the null hypothesis. Now, what happens as our p-value increases? At 0.01%, instead of a 95% chance that the difference is due to something other than chance, it is now a 99% chance. And what happens to the value here? It increases. So the higher the chi-squared value, the lower the p-value, right? This is decreasing. And then the more or less likely that the observed values would have occurred under the null hypothesis. In other words, support the null hypothesis, okay? Now, the higher the chi-squared value, right? The higher the chi-squared value, if my value is 7, if my threshold is 7.81, the higher the value at or over that threshold, the more likely the chance that the difference between the expected and observed data is due to something other than chance, which would mean we would reject the null hypothesis, okay? So this would mean that it would be less likely that the observed values would have occurred under the null hypothesis, which is answer choice A.